So, you like ever have a conversation with somebody, and as you're talking to them, you don't realize you're offending them? Yeah, I woke up this morning. That's about how often that happens with me in my world. I apologize. I was talking with the guy on this box that I'm getting ready to work on here. I'll tune this out to 14.6, we'll say. Come on. 14. Anyhow, I called to tell him what was going on with his little 1x2 that we're working on this morning, and he goes, "Man, my new 10K comes in." I said, "Oh, dude, would you get a 3000 or something?" Or no, what I said, I think I said it in the most asshole tone that you can possibly say it. I literally said, "Did you get yourself a little 3000 or something?" I'm sorry, guys. And I'm sorry to the owner of this, Mr. B. Not this, but what I'm going to work on here. Dude, that was not my intention. He was very excited, and I basically come along and farted all over his parade, and I'm sorry. That was not my intention. Most of the guys that I'm surrounded with were well past the 10K mark, and we're in the land of stupid, retarded, not necessary land. Me personally, it's like I went on to try and tell him. I said, "Man, I wish I could go back and run a 3000. That was easy." It is. A 3000 is so easy, man. You throw up some 217 coax. You can still run a Bird 43 line section. You don't have to have like a stupid service come into your house. You just got to give it like 50 to 100 amps worth of current, and man, it's just easy. 3000 is just, and I'm not saying this from it's a mud duck thing. It's not. A 3000 is a significant step forward. Huge step forward from a pillbox. That's it's just I've been in the 50 kW plus club now for a long time, and it just rolled off my tongue, my man, and I apologize to you, and I thought I'd come out publicly and say sorry. I think you're going to have a ton of fun with it. I mean, a 3000 set up right will make a ton of power. In my opinion, I think the 3000 is one of the best built tubes for this game. Cool. Okay, so y'all are going, "What the hell are we doing, BBI?" These are my last two Sunbeams / 12 volt 30 amp switchers I have up in this joint. I quit using these a long time ago, and I try to keep one or two of them just kind of chilling on the shelf, because there's a lot of guys that use these, and a lot of equipment comes in here where they need a power supply, and I got to make sure I got the right part. Okay, so that situation has presented itself here with this current situation, and I'm going to need two replacement supplies. So these are brand new out the box. I got them set 110 volts. They're trimmed to 14.49 volts. Don't bump. And let's look at our problem child that we got going on here. I don't know where this came from, because I've never seen Joe in the Carolinas build like this. I know Dave doesn't build like this, but it's a Davemade cabinet. I don't know if it's repurposed or what the deal is. I don't know. It's outside my wheelhouse. Okay. We have two burn power supplies. It's got 110 volt going in, nothing coming out of these. Nothing. They're done. The problem lies down in here. These are 2879Cs. Okay. And this is before everybody figured out that you've got to change all the circuitry around the transistor to actually make it work properly. The solder work in here is not the greatest in the universe. It's okay, we're going to fix all of that. If we look at our power wire, I'd have to have an argument to say it's a miracle the power wire doesn't fall off. So we've got to redo that. Our output wire is not connected, although the tab on the relay is present, but the wire is not connected. This capacitor here, these are two 500s, which means that was 1,000 puff of total capacitance. That means that this circuitry, and of course the input capacitor here is a 330, that means our circuitry surrounding the transistors is more in line and more indicative for a 16D08 or Toshiba 2879, not the 2879C. The other thing we got going on is this one 2879C driving two 2879Cs, and the output capacitor is not soldered in. When I started looking at this last night, I just touched it and it fell off. That is way bad. So I'm going to replace this with a 2290, because the 2879C driving two 2879Cs, which we all know are incredibly lower drive and very, very, very delicate transistors. I'm not going to lie to you guys, I'm going to take the 2879C off. I've got a couple of them in here for repair, and that's it. I am passing over, taking a hard pass on the 2879C. I evaluated those. This is one of the evaluation test pieces that I received probably 5 years ago on this component. And I felt that there was issues with it then. I haven't seen any of those issues get addressed with the current rev that's out on release. So I'm passing. I'm going to take a hard pass on this component. You cannot, and I've covered this in multiple YouTube videos, you cannot take the HG 2879 16D08 or Toshiba out of an amp and replace it with the HG 2879Cs. The 2879C requires a completely different circuit. Or the 16D08 just requires a little bit of change. The 2879C requires a lot of change. So he wants me to also add bias to this. It does not have any bias in it whatsoever, but it does have a sideband delay capacitor up here in the front. On a 3-position switch, it is not labeled. Preamp on a 3-position switch that's not labeled, so these two switches need to be replaced and labeled. 2 power supplies, and then let's talk about air management. There is none. So we have 2 sun-on fans, 120 millimeter fans pressing air in, and we've got the whole back of the cabinet, including the power supply, because this is a mobile cabinet, left wide open, so the air can just rush out any which way it wants. The heatsink stops right here on this board. So from here to the back of the cabinet, there is nothing, and it's just a dead open space. There is nothing in this cabinet to help motivate getting the air to go through the heatsink and actually cool anything. So that's all got to be changed. It's okay to do that with the DC wire, but not so hot when it comes to AC power. So we've got to actually put a real strain relief in that, make it a little bit safer. Other than that, oh, this is great. It's a fine built amplifier. I don't know who built it. I'm not pointing no fingers at nobody, because we don't know who built it here. We don't know. Never seen one built like this, so don't know. Other than that, wrong transistors, bad power supply, bad solder work, stuff disconnected, shit splooged all over the place. This is a very fine built piece of equipment. Tongue in cheek. So Mr. B, I apologize to you. Hopefully I didn't hurt your feelings this morning. I think it's awesome. I cannot wait for you to tell me tonight what you're getting out of your 3000, and hopefully you're very, very happy. Very happy. In the interim, we're going to strip this mother son of a bitch, and we're going to take it completely down to nothing, and we've got to start over. I wanted to showcase this as well. It showed up with one screw floating around in the packing material. And I looked at that and it was too big to be a case screw. And then when I got into the amplifier, I understood what was going on. Power supplies are held in with one screw. I mean, the holes are there, just I don't know where the screws are at. So I don't know. I don't know. I just on the phone with Crusher Built, and we were talking about why nobody gives a shit when it comes to airflow management. Turn down our exposure so you guys can see a little bit better what's going on. So we got a crack here in the board, and it is taken off. And what's causing that is the heat sink on this particular board only comes to here instead of going all the way back to the back edge like it used to. It used to be just about a 1-inch square that all we had to do was compensate for, but I mean, this little 1x2 is not going to generate that much heat, but it's like, damn, really? The other problem is the front edge of this board is completely unsupported. So we're riding up against this edge as our mount down, and we only have these two holes that are actually utilized. And then the tabs for the coax connector. So we're going to bolster that. I'm going to come back through, we're going to solder this corner here in a minute after we get it up inside the cabinet. And what I'll do is I'll bring the ground leads up and we'll create a solder bridge to help support this crack and keep it from it will stop the crack that way. And then out here on the outside corner edge, I'm going to drill and make a long screw or bolt that comes through, and we'll bolt this corner down. That way it's got 4 points of attachment, this side to back side and then this side. So 1, 2, 3, 4, 5 points of attachment to support it. By us blocking off this heatsink here, the vent in the back, we've now, what we're creating is a tunnel effect. We're controlling where and how the air is going to move through this deck. You see that? So you're going to have a vent here, and all of this is going to be vent. So we've gone and created this piece of phenolic, which will sit on the inside, be held in place by this ground nut, and it'll block it all off. So all the air that goes inside the deck this way now has to wrap across the switchers, which by the way weren't blown. Come to find out there was a hard, badass short that was going on, big time. And it was causing the switchers to go into crowbar protection. Okay? So it's going to cause all the air to blow across the switchers and then actually across the heatsink and then out the back of the box. The other thing we did is I added these little lips across the back of the board. As we all know, these vertical openings, if we can look down here, you'll see the vertical openings actually come up past the board layer. Air is like water. If we let air flow, because that's our board line right here. That's the board line. If we let air escape out of the top portion of these vents, you're going to have a low pressure and then a high pressure. Okay, you're going to have a pressurized air moving right by a low pressure, which is going to cause all kinds of flow issues. So what we want to do is we want to block this off as much as we can. That way we have the least amount of resistance of air leaving the bottom side of the cabinet. We want air to go across those heat sinks. We have to have air go across those heat sinks. Leaving this wide open like what it was across the entire back of this box will not, never will, and never can work. It took, what, an hour and 40 minutes to take this thing apart, strip it down to this point, identify all the problems, build the extra little pieces. If we would have done this from the outset, this is like an extra 15 minutes worth of work and probably would have saved the customer a ton of time and I know a lot of money. But this is where we are. So I'm going to get this mounted up. I'm going to dry fit everything. Then I'm going to pull the board back out of the cabinet. And then we're going to rebuild the board and get it all up to snuff. And then we'll put this whole mess back together. Put the Harbor Freight extension cord back in here. But it's going to go through a real strain relief. Real strain relief. All right, next. Okay, So let's start here. Now, like I said in the previous segments, this amp is set up to run the 16 D08s, not the 2879Cs. I just want to take a minute and let us all slowly bask in the quality of the workmanship that's gone on in this amplifier. This is our preamp circuit over here, and this is twisted lead. Your receive wire comes in here. Your antenna, okay, so your antenna wire comes in here, your wire that goes to your radio comes in here. This is your receive line. Okay, so your antenna is going to come through, it's got to go through this pin. Need a better pointing tool. Your RF comes in from here, goes down inside the relay, comes back out, and goes through this wire, twisted lead. Goes through this lead, comes all the way across the amp, goes through the preamp circuit, which is here, goes through this mess over here, if the preamp's on or not, then it returns back out, goes through the twisted lead, all the way back over to this connector. Then it goes back down through the relay, and then it goes out to your radio. That's scary as fuck to me. This twisted lead's bad. This is... you gotta think how the RF is moving, and it's polarizing both sides of this wire, and it's going to couple to each other this way. And by you twisting the leads, you're constantly taking the two phases and you're putting them 180 degrees out of phase over and over and over and over and over and over, or 90 degrees out of phase, however you want to look at it, or 360 degrees out of phase over and over and over and over again. This has all got to get changed. There's no way to make this work electrically correct to where it's going to be safe and not damage your radio. While we're here, we're going to take a look at our power strip. This has nothing to do with functionality as far as making this work, but as we can tell, somebody was trying to solder here, some dribbled over on the board, they didn't catch it, and then they had to sit here and scrape with a screwdriver to try and stop the short. Our output capacitance is 150 puff. Our input or output capacitors on our transformer are two 500 puff capacitors. These are 120s. This would be incredibly different. This would be 1600 puff. If we were going to use 2879Cs, the input capacitor, instead of being 230, would be in the closer department of 600 to 800 puff. Now to the driver section. This is a 2879C. This is a 500 puff capacitor. I don't know what they were setting this up for, but it wasn't soldered like I said. It was sitting like this when I got it, and I just pressed on it and it popped off. So let's come over here and let's evaluate what we got going on here. We got 4.1 disc capacitors. That's okay, I can live with that. And these are, what are these? You might actually be able to see from your angle better than me. 3 1000s. Okay. So we're set up for a 2290. No capacitance on the input transformer. And then here we've got a 100 puff. So this has got to change. He wants me to set this up so it's got a low or a medium or a high or at least a variable in it, which we can totally do. We just got to drill a hole in the cabinet up here, and we're going to put a variable in it because this is an incredibly low drive box. It's going to be a 20 watt box. But let's take a minute and come back down here and let's look at the quality of the solder work that's going on here. I've seen way worse. I've seen way worse. So I'm going to look at this as a complete rebuild. I got to move this. This has got to come back over here. This shit's got to go away. I got to replace this coax. We're going to change out this transistor, these true transistors. I'm going to replace this with a metal clad capacitor. This is the next major thing that always fails and gets hot. I'm going to replace the power distribution bus with something that's cut square. I mean, we don't really have to, but if you're going to take pride in what you do, you probably should. And it needs a bath. We need to clean this up a little bit. I'm going to do this first, then we'll fix all this, then we'll fix all of this, power wire upgrades of course, and then we'll move this after we get it in the deck. So we get this in here, and we'll bring this the rest of the way home. Okay, we'll see you in about 3 hours. Okie doke. So here we are. Placed our power strip, got both the transistors out, redid most of the solder work on here so it'll look a little bit more humanly presentable to the universe. Washed everything out, got all the thermal cream out of there. The pockets were just packed full of thermal cream, but as I'm cleaning out the pockets, I'm finding lots of little metal hunks like this. So the transistors definitely weren't sitting flat. If you look in here, you'll see there's a bunch more little flakes of metal and solder and shit. The pill pockets don't look to be that bad. They are definitely flat. There was a lot of stuff stuck down in here underneath the leads of the transistors that had me kind of concerned. That's why I went ahead and I washed it and just made sure to get all the smaller debris out of the thing. Come on, here we go. Okay, we're going to start putting this back together. I'm going to put two 287916 DO8s in here in a 2290, the way it should be. And we're only talking maybe a 100-watt increase by going to these transistors, but this is our driver, and these are our two final transistors. I'm assuming they're still good, taking into account the electrical short that I found inside the cabinet is what was keeping everything from turning on. But assumptions are like assholes. Everybody's got them. Yeah, we don't really know what that equates to. So let's take a hot minute. Personally, I'd be just tickled pink if these were good 2879Cs and I could send them back to the customer and he would have them. I don't care. So we'll see what we got here. This is our driver transistor. Let's fire this up. I don't need to show those off anymore. It's going trash. Driver transistor is shorted, no component detected. Let's go look at our final transistors. I mean, if they would just make the die thicker, the actual cut wafer portion, this has got a gain of 23. If they'd make the wafer thicker on the transistor, they would have a lot less failure rate and we'd have a lot more reliability. But I'm not a transistor engineer. I'm just a guy that likes to talk to himself in his shop. This has got a gain of 15 on it. So almost a 10 HFE gain difference between these two, but they are still technically good. We're going to set those aside. This one is garbage, so we're going to throw it in the giant bag of shame. And after my customer gets done watching this video, he can tell me if he wants to not care about these and I throw them in the bin just in case somebody needs them for a repair in the future, or if he wants them back. I don't frankly care. Either way, they ain't going back in this amplifier because I'm not going to go and bother to modify the whole circuit and change everything around, go to the longer transformer, change out the 8 caps and rewind everything to make it work for just 100 watts of power. All right, let's put parts on the board and let's get on with this. So got the board back in, got the power wires hooked up, fixed the crack. I'm going to support this corner just here in a second, but the other thing I did is I'll show you that here in a minute. What we're looking at now is the our pass-through tune. So we got our KC901 out and we're sitting here and we're looking at, it's like a 1.5 all the way across the board, these leads. These, I'm just not happy with this camera the way it's working out for me today. With these leads, this is our entire pass-through circuit. Look at it moving up and down. I want to see if I add a capacitor to one side of this thing, if we can get that SWR to pass, or get the pass-through to drop. Let's see, is this a 20 puff? Yes, no. It's a 200. I can't use that. Wrong value. 27. Let's take a cap and reach down in here and touch the cap to the board. Boom, just like that. You see that? Maybe I don't have to completely relocate the preamp circuit. Huh, okay. Well, we now know how we can go about fixing that. Let's shut this off here for a second. We'll disconnect this. Let's go ahead and set this up here front and center. So we fixed our short. So now we got power supply control, but look at this switch. The switch is busted. And this is what controls our preamp. And that's our sideband delay. Now, I just talked to the customer. He's like, yeah, it's got all them switches on the front, but it doesn't do anything. But it should. He said he bought this new right off the Davemade Moby webpage. I'm just like, man, this doesn't look like their handiwork. Alright, let's turn the preamp on. Okay, the preamp is working. I gotta replace all the switches. I'm just gonna replace all the switches. This is a 3-position switch and it only should be 2. This is a 3-position switch, on, off, on. This is an on and off, but it's intermittent, so. Let me fix. So we put some labels on the front of it and we fixed all of the switches, as in we fully replaced them. These are all brand new switches, all tied together. It's literally on or off instead of 3-position bullshit. Fixed what they actually went to. Tied the lines together. He's telling me he bought this directly from Joe. And my God.